When you look up at the night sky, seeing thousands of shimmering stars scattered across a black, endless canvas, have you ever wondered what lies behind them? Are they arranged in any kind of order? And just how vast must the universe be to contain all these wonders? To answer these questions, we need to embark on a journey that takes us from the smallest, most familiar objects like planets to the largest structures humans have ever observed. Prepare yourself, because the universe is not only vast, it is far beyond anything our imagination has ever tried to grasp. We begin our journey with planets, the places where humans stand live and gaze at the night sky. A planet, according to modern astronomy, is an object that has enough mass to become spherical, orbits around a star, and most importantly, has cleared its orbital path of large debris. Earth, our home, is just one of 8 planets orbiting the Sun. Mars with its dusty red plains, Venus with temperatures hot enough to melt metal, Saturn with its stunning rings. These are the first bricks that build the structure of the universe. What makes planets especially intriguing is their sheer number. Thanks to modern telescopes like Kepler and TESS, astronomers have discovered over 5,000 exoplanets. And the list keeps growing every year. Even more exciting, many of these planets lie in the habitable zone, where liquid water can exist. One of the key ingredients for life. Right now, somewhere in a distant galaxy, there may be another world taking its first steps toward life, just as Earth once did. Beyond planets, we reach stars, gigantic glowing spheres of plasma powered by nuclear fusion at their cores. Stars are the hearts of the universe. The Sun, the closest star to Earth, is just an average star among hundreds of billions in the Milky Way. It has been shining for 4.6 billion years and will continue to shine for another 5 billion. When its fuel is exhausted, it will swell into a red giant before collapsing into a white dwarf. But not all stars are the same. Supergiant stars can shine millions of times brighter than the Sun. Brown dwarfs never got enough mass to ignite fusion. Binary stars orbit each other in beautiful celestial dances. Supernovae, the explosive deaths of massive stars, can outshine entire galaxies. The most astonishing fact is this: when stars die, they scatter elements such as carbon, oxygen, and iron, the very materials that build Earth, plants, and even human bodies. We are literally made of stardust. Before a star forms, it starts inside a nebula, a massive cloud of dust and gas spanning dozens of light years. Nebulae are not empty or shapeless. They are among the most breathtaking structures in the universe, captured beautifully by the Hubble and James Webb telescopes. The Horsehead Nebula, the Pillars of Creation, the Orion Nebula. Inside a nebula, gravity pulls particles of dust and gas together, making them denser and denser. When a clump grows massive enough, nuclear fusion ignites, and a new star is born. Interestingly, nebulae may also be the remnants of stellar death. A supernova explosion scatters gas and dust into space, eventually becoming the birthplace of new stars. The death of one star gives rise to another, the universe's eternal cycle of creation and rebirth. A star rarely exists alone. When it forms, its gravity gathers surrounding materials, planets, moons, asteroids, comets, and dust. These components form a star system or planetary system. The best example is our solar system. 8 planets, hundreds of moons, thousands of asteroids, countless icy bodies and comets. Within the Milky Way, there are hundreds of billions of such systems. That means the galaxy is filled with worlds we have yet to explore, worlds where oceans may flow, continents may rise, and perhaps life may exist. Stepping higher on the cosmic ladder, we reach galaxies. A galaxy can contain anywhere from a few million to several trillion stars. They come in many shapes. Spiral galaxies, elliptical galaxies, or regular galaxies. Our home galaxy, the Milky Way, is a majestic spiral with swirling arms containing gas, dust, and stars. At the center rests a supermassive black hole called Sagittarius A. The Sun is just one tiny star located quietly on the Orion Arm, far from the turbulent galactic center. Galaxies also contain dust clouds, star clusters, dark matter, and countless planetary systems. Even on the darkest, clearest night, almost everything you see with the naked eye is still within our Milky Way. The entire universe, however, contains around 2 trillion galaxies, each a majestic city of stars. Galaxies do not float alone. They gather into galaxy clusters, bound together by immense gravitational forces. A galaxy cluster can contain dozens to thousands of galaxies, rivers of superheated plasma, enormous concentrations of dark matter. The local group, the cluster we belong to, contains over 50 galaxies. The Milky Way and Andromeda dominate this group, surrounded by many dwarf galaxies. In massive clusters, gravity is so strong that even light bends when passing through, creating a phenomenon called gravitational lensing, a tool that helps astronomers observe regions far beyond normal reach. Beyond clusters, galaxies organize into even larger formations called superclusters, the biggest cosmic structures ever discovered. Our galaxy is part of the Laniakea supercluster, which stretches over 500 million light-years and contains hundreds of thousands of galaxies, thousands of galaxy clusters, a gigantic network of dark matter. If a galaxy is a city, and a galaxy cluster is a country, then a supercluster is an entire continent. What's even more astonishing, Laniakea itself is only one supercluster among countless others scattered throughout the universe. Everything we can see, planets, stars, galaxies, is only the tip of the iceberg. Just 5% of the universe. The rest consists of purple circled 27% dark matter. Invisible, undetectable directly, but powerful enough to hold galaxies together. Blue circle 68% dark energy. The mysterious force accelerating the expansion of the universe. Dark matter acts like the skeleton of the cosmos. Dark energy acts like the engine pushing everything apart. Without these invisible components, the universe as we know it would simply not exist. Though it may appear random, the universe is astonishingly structured. Galaxies connect with each other through massive cosmic filaments, forming a structure known as the cosmic web, one of the most breathtaking patterns ever discovered. The cosmic web resembles the neural network of a gigantic brain, except it stretches across hundreds of millions of light years. This is the deepest, grandest architectural design the universe has revealed to us so far. Telescope 10. Why understanding the structure of the universe matters. Because understanding the universe also means understanding ourselves. When we look at the stars, we realize where we are, how small we are, how rare and precious life is, and how many mysteries remain to explore. Every layer of the universe, from planets to superclusters, tells a part of the story of our origins, our present, and our potential future. From a tiny speck on Earth, we gaze outward and discover that the universe is not just a collection of stars and galaxies. It is the greatest story ever told, and we are one of the countless chapters within it. Keep exploring. Keep observing the sky. Keep your curiosity alive. Because we are more than just residents of Earth. We are citizens of the entire universe.